Chapter 8, Section 8, Angles in Polygons. A very important number to remember is that the number of degrees in a triangle is always 180. So, if you know one or two of the angles, you can always figure out the measure of an unknown angle. This triangle, I'm going to let you know that the degrees for this angle are 50. And I'm going to indicate that. So what do we know about this triangle? We know that one angle is 50 degrees. Well, we know what this symbolizes. This means it's a 90-degree angle. So we know there's a 90-degree angle plus some unknown angle, I'm going to call it A, will equal 180 degrees. So to use our order of operations, we're going to solve for A. 50 plus 90 is 140, plus A will get us 180 degrees. And then we're going to solve for A. I need to get A by itself, so I'm going to get rid of the 140. What I do to one side, I must always do to the other side of my equals line, sign rather. So that crosses out, leaves me with A, and A equals 40 degrees. So I knew two of the angles, and I could calculate the third one because I knew that every triangle had a 180 degrees in it. So now we have some other possibilities. We have a triangle, and it has the measures of 55 degrees, 80 degrees, and an unknown x. So I know that 80 plus 55 plus x should equal 180 degrees. Always in our triangle, 180. So every triangle is 180 degrees. So let's combine 80 and 55 and get 135 plus our x still is going to equal 180 degrees. So if I need to get rid of the number attached to my x, the opposite of adding is subtracting. I subtract 135 from both sides. And always what I do to one side, I need to do to the other. So we combined our like terms and we subtracted 135 from both sides. So 180 minus 135 would be, borrow from my 8, 5, 45 degrees. So the measure of my unknown angle is 45 degrees. So now that we know about triangles, we can use that information to do other polygons, and let's start with a quadrilateral. So we have the degrees 65, 89, and 82. Well, I'm not even sure how many degrees are in a quadrilateral. I can figure it out because I can take this quadrilateral and turn it into two triangles. If this triangle's 180 and this triangle's 180, then I know that the sum of my quadrilateral, when I add up all my angles, will be 360 degrees because it's really made up of two triangles. So I'm going to combine my like terms and I'm going to subtract 236 from both sides. I have to bring my 360 down, it's coming straight down here. So I'm going to subtract 236 from 360, borrow from my 6, I get a 4, I get a 2. So that angle is 124. And does that make sense? Is this an obtuse angle? I definitely think it is. So it had to be more than 90. So that definitely is an obtuse angle at 124 degrees. So let's look at some other polygons and their size of their angles. All right. Wow, here's a polygon for us. So let's look at this polygon. Let's see how many triangles we have. I'm going to pick one vertex, get my dot there, and draw a line and make a triangle. Now every triangle I make is going to come from just that same vertex as I'm drawing down to a vertex across from it. So one triangle, a second triangle, third triangle, fourth triangle, fifth triangle, and there's number 6. So I got 6 triangles out of this polygon. 6 times 180. 6 times 0 is 0. 6 times 8 is 48. Carry my 4. 6 times 1 is 6 plus 4 is 10. So this polygon has 1,080 degrees because there were 1, 2, 3, 4, 5, 6 triangles. So let's see if our theory holds out for us. A quadrilateral has 4 sides. Here's my quadrilateral. If I make a line, how many triangles do I get? 2. I now have a pentagon. Here's my pentagon. It has 5 sides. 1, 2, 3, 4, 5. I can make a triangle here, and then from the same vertice, I draw my line here. So I get 1, 2, 3 triangles. 5 sides gives me 3 triangles. 4 sides gave me 2 triangles. Let's see about our hexagon. 1, 2, 3, 4, 5, 6 sides. I pick one vertex and draw my lines out. And I get 1, 2, 3, 4 triangles. 6 sides gave me 4 triangles. Do you see a pattern? 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So the number of triangles is always 2 less than the number of sides. So if I had a decagon, and we know that a decagon has 10 sides, and I wanted to know how many triangles that would be without having to draw it, 10 sides minus 2 will give me 8 triangles. And then I could take those 8 triangles, multiply times 180, and see how many degrees were in a decagon. So let's do some more practice with that. Angles inside a polygon are called interior. 55, 35, and of course that would be 90. And it will always equal 180. So a quadrilateral formed 2 triangles. Excuse me. Quadrilateral formed 2 triangles. A pentagon formed 3 triangles. A hexagon will form whatever 6 minus 2 is. 4, that's right. A septagon, and we also have called this a heptagon. Same thing. Would be 7 minus 2, which would be 5. And then octagon number of triangles would be 8 minus 2, which would give me 6. So let's look at our pattern. How many triangles in a hexagon? Well, there's 4, because 6 minus 2 equals 4. How many triangles in a septagon? Well, septagon has 7 sides. Minus 2 gets me 5. And triangles in an octagon? Well, an octagon has 8 sides. Minus 2 gets me 5. So if I had an octagon with 8 sides, minus 2, that's 6. 6 times 180 degrees, 1080 degrees. So we can figure out the number of degrees in any polygon by taking it into triangles or doing our side minus 2. That's the end of section 8-8, Angles in Polygons.